Hello, Peyton.
Hey, did you get my email?
I did. I'm just opening it up now.
Okay.
We doing more verifying tonight?
Yeah, kind of more along that, yeah, more kind of along that lines, I guess.
No, it looks like you're getting into inverse trig functions.
Yeah,
All right. We're done with the verifying, I guess. Okay.
yeah.
Um, Should we start at 21?
Yeah, yeah, let's start at, let me think. Let's start at number, yeah, let's start at 21.
Okay. First of all, let's make sure you understand the concept.
Okay.
The sine of 30 degrees equals what? You remember?
Isn't that, isn't it
One half.
1?
One half. If you're going to memorize any trig function of any angle, memorize this one.
Okay.
Okay? And what that means is that the inverse sine of 1/2 equals 30 degrees.
Yeah.
In other words, we take trig functions of angles to get ratios. We take inverse trig functions of ratios to get angles. So
Okay.
when we're dealing with inverse trig functions, we're always dealing with a number and trying to come up with an angle. Okay.
Okay.
So this first one, we're going to work from the inside out. Actually, we're going to do this a little different.
Okay.
I came up with a very clever way of doing these, and I haven't always known this way. First of all, is that an angle inside the bracket?
Um, I don't think it is.
Yeah, remember what we do. We take inverse trig functions to come up with angles. So I'm going to
Okay.
call that angle theta.
Okay.
Now I'm going to draw a triangle. And I'm going to label theta right there. Right triangle.
Okay.
And how much of that triangle can I dimension, and where should the dimensions go?
Um, um,
This side, square root of 2. This side, 3.
okay. And then
Hold on. Just take it step by step. Now
okay.
you can finish. Don't worry about the negative sign for the moment. Okay?
Okay.
The best way to do trig is to figure out the absolute value and then figure out whether the sign should be plus or minus or not.
Okay.
When I do this technique where I just draw a triangle, well, okay, now finish dimensioning the triangle. What's this side over here?
it's going to be that'll be this like
It's the square root of the hypotenuse squared minus the other short side squared.
wouldn't that be the square root of 7?
Uh-huh. Now, what's the cotangent of theta?
The cotangent of theta is going to be isn't that going to be like the square root of 7 over 3, right?
Over square root of 2.
Oh, over 2. Okay. Oh yeah.
No
Opposite over.
cos. tangent is opposite over adjacent, therefore cotangent has to be adjacent over opposite.
Okay.
Okay? Now, let's figure out the plus or minus sign on it. First of all, what quadrant? Notice we've figured out the cotangent of theta without knowing the theta. We didn't go into a calculator and figure out theta. We could have, but that's not the best way to do it. You can answer all of these questions without knowing what theta is.
Okay.
The only thing we need to know is what quadrant it's in. Well,
okay.
Where is the sign negative? There's only one quadrant that is considered the principal quadrant where it's negative.
Wouldn't that be the third quadrant?
The fourth. It is negative in the third, but that's not what your calculator gives you. If you put this into a calculator, inverse sine of negative square root of 2 over 3, it would give you a fourth quadrant angle only. It doesn't even tell you what the third quadrant angle would be.
Okay.
So you have to know your principal angles. For sine and tangent, it's first and fourth.
Okay.
For cosine, it's first and second. In other words, if I gave you this, I'm talking second quadrant.
Okay.
If I give you this, I'm talking fourth quadrant. If I give you this, I'm talking fourth quadrant. If I give you this, I'm talking first quadrant. So you have your principal quadrants. For sine and tangent, they are the first and the fourth. For cosine, they are the first and the second. You just have to memorize that.
Okay.
Okay. Now, so we know that theta is a fourth quadrant angle. Without knowing what it is, we know it's in the fourth quadrant. Therefore, what's the sign on cotangent going to be? We got the number. It's root 7 over root 2, but is it plus or minus?
Is it going to be minus?
Uh-huh. In other words, we know that only because we know it's in the fourth quadrant.
Okay.
Okay. Notice that if I could have used the third quadrant answer, which would have been perfectly acceptable, it is true that the inverse sine of this number, you can find a third quadrant angle for that. And had I used the third quadrant angle, well then cotangent would have been plus, not minus. Cotangent's plus in the third quadrant. So this business of knowing the principal quadrant is very important. Okay? Because this is a perfect example of it. You're not just figuring out where the sine is equal to minus root 2 over 3. There are two quadrants where that is true. There's the fourth and there's the third. But your calculator is only going to give you the fourth quadrant answer. So that's considered to be the principal one. And that's what's used to finish this problem. All right. Let's take the second one here. We have cosecant of inverse tan of negative 2, and let's do it exactly the same way. And just to review, the way we're going to do it is call that theta. Very important. Very important to do that step because that reminds you of what the next step is. What's the next step? Draw a right triangle and label theta. This theta right here. It's always the next step. If you do this process every single time, you'll get 100% on these. Okay? Now, dimension as much of that triangle as you can.
Well, won't.
Ignore the negative sign in front of that 2 for the moment.
Okay.
We'll get to that in a minute. In other words, that's going to tell us what quadrant we're in. But
Okay, well,
it's not needed to dimension this triangle.
okay, well, wouldn't the well, isn't the opposite? Isn't that going to be 2, and then the hypotenuse, isn't that going to be
Not the
1?
hypotenuse. Remember, tangent doesn't involve the hypotenuse.
Okay.
Tangent is
Okay.
opposite over adjacent.
Okay.
Only
Yeah, that's what I
sine
meant.
and cosine directly go to the hypotenuse. As far
Okay, yeah, that makes
as
sense.
SOHCAHTOA goes. Okay.
Okay.
Now you got 2 sides. You can use the Pythagorean theorem to figure out the third side. What's
That'd just be 4 plus the square. That'd be the square root of 5, right?
Uh-huh. You're actually very good at solving right triangles. Know that you are. I've never seen you get one wrong yet. And now we figure out what quadrant theta is in. Well, what quadrant is it in?
Well, aren't tangents aren't they always in like the same quadrant as?
There is a principal quadrant for positive inverse tangents, and there's a principal quadrant for negative inverse tangents. If this was a positive 2, they would mean quadrant 1. If
Okay.
it's negative 2, it's quadrant 4, just like sine.
Okay. Yeah.
So that is fourth quadrant. And let's write it like that. Because
Okay.
now we're going to figure out what the cosecant of the angle is. Go ahead. What's the cosecant of theta?
That's going to be that's going to be square root 5 over 2, right?
Yeah. Oops. My mind got ahead of itself. And what's cosecant in the fourth quadrant? Positive or negative?
It's going to be positive, right?
No. Cosecant is the reciprocal of sine.
Oh.
Sine is negative in the fourth.
Okay. Yeah. Okay.
I remember all students take calculus. All students take calculus. That means
Okay.
fixed or positive in the first, only sine, and obviously it's reciprocal, cosecant, are positive in the second, only tangent and cotangent in the third, only cosine and secant are positive in the fourth.
Okay.
That process is exactly what we're going to use on every single problem that we're looking at least these first 8.
Okay.
All right, so let's make sure you can do it. Sine of inverse tan of negative 3. I used to actually do these different using a calculator. I would do the inside, figure out what that angle was, and then take the sine of that angle. In other words, I'd go through the same procedure, but notice we've been able to answer these, every one of them, without knowing what theta was. We never
Yeah.
figured out what theta is, and this is the way you're supposed to do it.
Okay.
So what's the next step? In other words, you're supposed to be able to do these without a calculator.
Okay. Well, the next step is to draw out theta on the right triangle.
Yeah, actually the next step is to know that that's theta right there. That thing that's inside the parentheses, inverse tan of negative 3, is an angle. We're going to call it theta.
Okay. Okay.
Now we do the right triangle, and very important, label which one is theta. Because I could label theta up there if I wanted to. Let's label theta up there. It doesn't matter. Now dimension that triangle.
Well, well, the negative 3 or the 3 is going to be on the opposite, or yeah, it's going to be on the opposite, and then 1's going to be on the hypotenuse, right?
Huh? Remember, tangent does not involve hypotenuse.
Oh yeah, yeah. I'll be on the
Your
adjacent
SOHCAHTOA.
value.
You're going to get lost in trig if you forget SOHCAHTOA. You got
Yeah, yeah,
to know that thing by heart.
yeah, yeah. It'll be on the adjacent end.
Okay, so the 1 goes there. Now, what's the hypotenuse?
Oh, it's going to be
I need the hypotenuse. I just don't get it from the tangent, the inverse tangent of -3. That's the third side that I need to figure out.
okay. The hypotenuse is going to be square root 10.
Now, what quadrant are we in? What quadrant is theta in? It's the next step always.
Isn't it going to be in the third quadrant?
Remember, tangent, positive in the first, negative in the fourth.
Okay,
So this got to be fourth. It's either
okay.
first or fourth for inverse tan and inverse sine.
Okay.
If we were looking at inverse cosine, it's either first or second, depending on whether it's positive or negative.
Okay.
Okay? All right. So we know our quadrant. Now tell me what the sine of theta is. What's the absolute value of it?
That's going to be the sine of theta is going to be 3 over square root 10.
Now, what's its plus or minus sign in the fourth quadrant?
It's going to be minus sign, right?
Uh-huh. That's how you do it. Notice we're doing every single one exactly the same.
Okay.
Okay. Now, we've only done 3 of them. I can't read 24. Let's try 25.
Okay.
We're obviously not going to be able to do them all. But once you see this technique, you're going to be able to apply it to every one of them. At least, I guess. The next set of problems, say that you find the exact value and verify it using a graphing utility, and that's not much. In other words, you're going to use a calculator on the next 8.
Okay.
Okay. First step here.
Well, the first step is to figure out what theta is, and then to put that on like a right triangle.
Okay, so we're going to draw a right triangle. What's theta?
Theta is um, 2 square root 5 over 5.
Huh? Theta is this whole thing. That's an angle. When you see
Okay.
inverse sine of a number, you're looking at an angle. That's why I write theta every time. In other
Okay.
words, I'm replacing what I'm looking at inside the parentheses with theta.
Okay.
Okay, now I'm going to label theta, and like you saw, I could label it either the lower right or the upper left, doesn't matter.
Okay.
Now you can dimension 2 of the 3 sides of that triangle. What are they?
It's going to be the opposite value and then the hypotenuse value since it's sine.
What's the third? You always have to figure out the third side.
Yeah, that's going to be
Part of the nature of it.
Like 25 minus 2 square root 5 squared.
20. Think square root of 5. It's a square root of 25 minus 20.
Oh, okay.
I think.
Okay.
Isn't it? It's the square root of the hypotenuse squared minus 2 root 5 squared. Well, that's
Okay.
square root of 25 minus, you square both of these terms, so that's 4 times 5, that's 20.
Okay.
So you get square root of 5. Okay. Now we got the triangle dimensioned. What quadrant are we in? What quadrant is theta in?
That's going to be in the well, since the angle is positive, isn't it going to be in the like the second quadrant
The
or the first quadrant?
The angle is not positive. The number is positive. This is
Oh,
a ratio. Remember, we take inverse trig functions of ratios in order to get angles. What I have
okay.
done is I have called that entire thing theta. That's why I
Okay.
write it like that.
Okay.
Okay? Is because that's an angle. And whether this is positive or negative tells us whether it's in first or fourth. So which one's this in?
It's going to be in the fourth.
Positive, is it not?
Oh, it'll be the first
Okay.
since it's positive.
Okay. Now let's figure out the absolute value of the secant of theta.
Okay.
What is that?
That's going to be it's going to be 5 over square root 5.
And finally, it's plus or minus sine.
It's going to be minus.
What quadrant is it in?
It's in the first quadrant, so it'd be positive, sorry.
Positive. In other words, that's the name of the game, is you got to do every single step here.
Okay.
You got to figure out that that whole thing in red is an angle that I'm
Okay.
calling theta. And then you could immediately figure out whether it's in first or fourth. I don't need to do this step third. I could do that right away.
Okay.
But then I draw the triangle, figure out all 3 sides of the triangle, which allows me to figure out a different trig function called secant of that angle.
Okay.
And if I know what quadrant I'm in, then I know what the sign on the secant should be, because I know what secant is. Secant is the same sign as cosine, and in the first quadrant, that's positive.
Okay.
Okay? All right. So let's have a look, see if there's anything special we can cover in the next 6 minutes here.
Okay.
These are all exactly the same. Well, they're not. No, they're not. 27 is a little different. The first 6 were all, notice that they were trig functions of inverse trig functions, whereas
Okay.
27 is the opposite. 27 is the inverse sine of the cosine of 3 pi over 4. Okay. So it's the inverse sine of the cosine of 3 pi over 4. Let me think for a moment here. Is what's in the parentheses an angle or a number?
Is it the well that's the theta, right?
No.
Or no, well there would be brackets, wouldn't there, if it
No,
was
that's not what determines it. The previous problems, notice, had the trig function on the outside, and on the inside was the inverse trig function.
okay.
This is not that way. This is the outside is the inverse sine function. On the inside is the cosine of 3 pi over 4. So I just am asking you, is this an angle or a number, what's inside the parentheses?
Well, isn't it a number since
Yes,
it's not the
yes,
inverse?
absolutely. It's going to be a number. Okay?
Okay.
So let me think if there's a clever way of doing this without figuring out what number that is. Certainly the hard way. Let's do it the hard way. What's the cosine of 3 pi over 4?
That's going to be um
This
um
is where you kind of need your unit circle memorized. Or you need to be able to figure it out. What quadrant is in? What's its equivalent first quadrant angle? How you get that from the two triangles? In other words, there's a lot of steps to knowing how
yeah
to solve that. We've been through it, but I don't know if you still remember exactly how to do it. That's that's in the second quadrant, is it not?
yeah no, yeah, it's in this
What's
it's
its
in the second.
equivalent first quadrant angle?
What?
What is the equivalent first quadrant angle for 3 pi over 4?
Well, wouldn't it just be pi over 4?
Correct. Now what's the cosine of pi over 4? That's a 45-degree angle.
Isn't that going to be like 1 over 1?
Square root of 2 over 2.
Oh,
Here's your 45-degree triangle. That's
okay.
why these two triangles, it's so vital to know exactly what they are.
Yeah.
Okay? Well, the cosine is 1 over root 2, which after I rationalize it becomes root 2 over 2.
Okay.
Okay? And didn't need to rationalize it really. I could have called it 1 over root 2. Now,
Okay.
it's in the second quadrant, so what is its sign? Positive or negative?
Isn't it going to be well, if it's in the second quadrant, isn't it going to be negative?
Yeah. So that's what is really inside the parentheses, is negative
Okay.
root 2 over 2. Always,
Okay.
always try to keep straight whether you're talking about an angle or a ratio.
Okay.
Okay? What's inside the parentheses originally was the cosine of an angle, which gives you a ratio. So I'm replacing it with its exact ratio, negative root 2 over 2.
Okay.
Now we're taking the inverse sine of that ratio. What angle are we going to come up with?
Isn't it going to,
Here's what we're doing. We're going to take the inverse sine of negative root 2 over 2. Well, to answer this question, first of all, let's call that theta. So the sine of what angle is equal, we'll just deal with the number part first. So what angle would theta be?
well, that would be that'd be 45, right? 45
But there's
degrees.
a negative sign in front of the ratio. So what angle is that? You got the
Well,
angle. It's 45, but now you need to know whether it's positive or negative.
well, it's going to be like negative since it's in a different quadrant, right?
Right, exactly. This tells you it's in the fourth quadrant.
Okay.
Okay, so in other words, the inverse sine of this is minus 45 degrees. Well, let's leave it in radians. If you were to input this problem into your calculator, and you have your calculator set on radians, you're going to get this as an answer. Notice that that is the negative 45-degree angle, which means it's in the fourth quadrant.
Okay.
Okay? And it's not going to, the sign is also negative in the third quadrant, but it's not going to give you the third quadrant answer. It's always, if you're taking the inverse sine of a negative number, you're going to get a negative angle less than 90 degrees, which means it's in the fourth quadrant.
Okay.
All right, Peyton. that actually covers a lot because we covered all the ones that have the trig function on the outside, and then we did one where the trig function is on the inside.
Yeah,
And
yeah, thanks.
just
Yeah,
keep them straight. Know which of these are angles and which of them are going to be numbers.
okay, yeah, thanks. Yeah, I just kind of need to keep going over him.
Yeah, yeah. Okay.
All right.
I
Yeah,
will
thanks.
I will talk to you next time.
Yeah, see ya. Bye.